All right. What do we know about parallel lines?
They're equally lined.
They're what?
Equally lined. Like they're straight, like equal.
They're equal.
They'll never touch each other.
They'll never touch each other. Very good. Yeah. Parallel lines are equidistant apart, I think what you were trying to say. They'll never touch each other. And think about never. Never is a very long time. Obviously, when we talk about lines, you know, it's kind of hard for us to think about, but they go on forever. They're infinite, okay? So for them never to touch, that's saying a lot. And what it means is they are the same distance apart anywhere you measure. They'd be the same distance apart. And there's something special about when we graph a line, there's a way that we can determine that they will never touch. Any ideas? Well, we usually say all lines are straight.
Wait, they both have the same slope but different lines.
Oh, look at that. The same slope. So let's write another line with the same slope, but a different y-intercept.
Yx.
All right, go ahead, give it to me. Y.
Y equals
1/2
x plus 56.
2.
Y plus 56.
2?
Mr. Zimmer, you did something wrong.
Oh, I forgot my plus sign.
And you also put the X.
Oh, you're right. Very good. Thank you.
You're welcome.
There we go. How's that? There you go. Plus 56. Okay. How about 26? Oop, we gotta make it a little smaller. Okay. But those lines will never touch. So parallel lines, the important thing for you to walk away with is parallel lines have the same slope. Okay. Now, how about perpendicular lines? Do you guys know what perpendicular lines are? No, perpendicular lines are not the same line. What do you think perpendicular lines are?
Oh, it's like this.
It's the complete opposite of parallel. I think they'd have the same y-intercept but different slope.
Okay.
Isn't like one
Parallel lines have the same slope.
Different y-intercept.
All right, but let's talk about just what are perpendicular lines first of all.
Don't they cross?
Like, do you see any perpendicular lines here?
Yes.
Yes.
The red and blue lines.
Okay. Well, there we go.
The red and blue lines.
Okay, the red and blue lines are perpendicular. What makes them perpendicular? They cross, but specifically, what else about them? So, well, let me say this line right here crosses the blue line. Are they perpendicular?
Yeah.
So you're saying this line and the blue line are perpendicular.
No.
No, they're not.
Okay, so what makes the red line perpendicular to the blue?
It is vertical. And the others are horizontal.
Oh, okay, so the blue lines are horizontal and the red line is vertical. Okay, if it makes a plus sign, it's perpendicular. All right, good. Looking for something more specific.
They're not the
A
same.
90-degree angle. Two perpendicular lines will intersect at a 90-degree angle. And we want to show 90 degree, we use this little square here
It makes it look like a chair.
to show they're 90 degrees. Just a little box there. All right, very good. So perpendicular lines intersect at 90-degree angles. Very good. That's what we call perpendicular. Okay, now back to our Desmos here. What determines if lines are going to be perpendicular when we talk about equations of lines? Any ideas? Opposite reciprocal. Very nice. So let's go back. What is opposite reciprocal? What does opposite mean?
Opposite, like different sides.
All right, so what's the opposite of 5?
Negative 5.
Negative 5. Very good. What's the opposite of negative 3?
3.
Positive 3. Who just said 2?
3. Positive 3. So the opposite is, if one's negative, the other one's going to be positive. So that's the opposite part. That's the easy part. What is reciprocal? Like flip. Sometimes we'll, instead of reciprocal, we'll say refliprical. So what's the reciprocal of 2/3? 3 halves. Very good. Okay, so what's the opposite reciprocal of 2/3? Would be negative 3 halves. Very good. So let's come back to that one. So here's where we get, you guys usually do pretty good. Let's do one more example. What's the opposite reciprocal of negative 5/7?
Positive 75.
All right, very good. Here's where we get messed up a little bit. What's the opposite reciprocal of negative 1?
0 over 1.
This dude needs to. I swear.
All right, well, first, this is negative, so we know the opposite's going to be positive, right? But how do you flip a whole number? There you go. First thing we got to do is make it a fraction, and then we flip it. But how do you flip 1 over 1? It just ends up being 1 over 1, right? Which is 1. So the opposite reciprocal of negative 1 is actually positive 1. And
It's gonna be on a test quiz.
yeah, what is the opposite reciprocal of 2?
Negative 2.
Negative 2?
Negative 1/2.
That's right. First we make it a fraction, and then we flip it, and we change the sign. The opposite of positive 2 is going to be negative, and the reciprocal of 2 over 1 is 1/2. So the opposite reciprocal of 2 is negative 1/2. Does that make sense?
Yeah.
All right, well, let's try a couple of these. Now, when we talk about parallel lines or perpendicular lines, do the y-intercept matter? No. The y-intercept does not matter. Okay, so let's do a couple of these. The first one we talked about was 2/3 and negative 2/3, right? First, let's get these a little closer together. And let's get back to these guys a little bit. Oops, we got to get bigger.
Never seen technology before.
How come we are so close together here?
She's like, what she's never seen.
All right, so there's 2 parallel lines. Let's start with 2/3. Now we got to go back a little bit. Let's change that slope to 2/3. So 2/3. That's the red line. Now we'll change the blue line to what would be the opposite reciprocal of 2/3? Okay, you guys said negative 3 halves. Those two look perpendicular?
Yep.
They sure do. And you notice the y-intercepts are still different, aren't they? Okay. If we made the y-intercepts the same, all it would do, they would still be perpendicular. It would just happen to bring those guys together right there. But they do not have to have the same y-intercept to be perpendicular. So let's change that back. All right, let's try the other one we talked about was negative 1 and positive 1. Just want to make sure you guys believe me on all this. So we'll go with positive 1 there and changing this one to negative 1. And there you go, still perpendicular, right?
Yes.
And what was the other one we talked about?
Negative.
2 and negative 2?
Yeah.
Okay, let's do 2 and then negative 2. Oh, do those look perpendicular?
Wait, it's negative 1.
Ah, very good. That's right. It's negative 1/2. That's the opposite reciprocal. And again, perpendicular, right? Okay, so parallel lines have what?
Have
Um,
90 degree angle.
Parallel. Oh, sorry.
Parallel lines have the same slope. Parallel lines have the same slope. So on worksheet 3.6, worksheet 3.6, let's write that down here, just off to the side. Parallel lines, let's just put same slope. Okay? And I'm going to put the symbol. What we say when we want to put parallel lines, we just put two lines like that next to each other. So they don't look like L's or I's. We make them a little longer than we need to, but we just make two lines like that. That means parallel. That's the symbol we use for parallel lines. And perpendicular lines,
Wow.
perpendicular lines, opposite reciprocals. And just for your knowledge, the symbol we use for perpendicular is an upside down T. Parallel lines have the same slope. Perpendicular lines have the opposite reciprocal slope. Okay. So, we already said we need two things to write the equation of a line. Either a slope or a y-intercept, or a slope and a point, right? If we have a slope in the y-intercept, we plug it into the slope-intercept form. If we have a slope and a point, we plug it into point-slope form, and then we can convert it to slope-intercept if they want us to. So let's take a look at number one. Write the equation in slope-intercept form of the line that passes through the given point and is parallel to the graph of the given equation. So, as always, we need two things to write the equation of a line. We need the slope and the y-intercept or a point. So they gave us this point, so we're going to write this thing first in point-slope form. Did they give us the slope?
Yes.
What is it?
2x.
It's not 2x, it's just 2. Because they want us to write the equation of a line that is parallel to the given line. Well, if it's going to be parallel, it has to have the same slope of this line, doesn't it? So they want a line that passes through this point but is parallel to this line. So we know it has to have the same slope as this line. So now what I'm going to do, I'm simply going to take my point-slope formula and I'm going to plug in the point and the slope. So it's y minus y1 equals the slope times x minus x1. Now guys, be careful when you're plugging that in. Last period, a lot of people were forgetting that it's minus -1. So now I'll simplify. So it's y minus 3 equals 2 times x plus 1. But did they want it in point-slope form? They want it in slope-intercept form, so I have to convert it, which is pretty easy. We will distribute, and we get y minus 3 equals 2x plus 2. Then I'm going to add 3 to both sides, and my final answer is y equals 2x plus 5. Does everybody see how I got from here to here without me actually adding 3 to both sides? Okay, good. Well, I'm going to leave number 2 for you guys to do on your own. All right, and let's go down and look at number 3. It says, write an equation of a line that passes through the given point and is perpendicular to the graph of the given equation. So the same thing. We want to write the equation of a line that is perpendicular to this line and passes through this point. So the first thing we need is our slope, isn't it? So what's the slope of our new line going to be? We want it to be perpendicular, so we need it to be the opposite reciprocal of this, right? So we know it's going to be positive, and the reciprocal of 3 over 1 is 1/3. Very good. So let's write this in point-slope form first. So I'm going to leave off, remember, this is x1 and y1. So it is y minus whatever y1 is, -2, equals 1/3 times x minus 6. So that's the point-slope form, but they want it in slope-intercept, don't they? So I'm going to simplify it first. Y plus 2, negative times a negative is positive, equals, I'm going to go ahead and distribute in this step. So 1/3 times x, that's pretty easy. It's just 1/3 x. And what's 1/3 times negative 6? Negative 2. And now I'm just going to subtract 2 from both sides. And we get y equals 1/3 x minus 4. Okay? So, determine whether the graphs of the given equations are parallel, perpendicular, or neither. Well, what do we need to compare these guys?
The points.
We need to know the slope. We need to know the slope, so we're going to probably put them in slope-intercept form, right?
Yeah.
So I'll take this guy right here, and to get him into slope-intercept form, we always want to think about getting y by itself. So I'm simply going to subtract 5x from both sides. And we're left with y equals negative 5x minus 21. Okay, and if we look at this guy, I'm going to simply bring him down, because he's already in slope-intercept form, isn't he? He's y equals negative 5x plus 9. Okay, so we want to compare their slopes. What would you say about their slopes? They're the same. So what does that say about these two lines? Okay, these two lines are parallel. Same slope, so and I'm just going to put this symbol parallel. So I'll leave number 6 for you to do, and 7, you're going to have to do a little work there. I'm going to leave that for you. So all I want you to do this weekend for homework, you could probably get it done after the quiz we're going to take in 2 minutes, is just do problems 2, 4, 6, and 7. Just finish the front side of this. Okay? That's what you're doing after the quiz.
Wait, can you go back to the number 5?